Now, when you're solving log functions, same thing with exponential functions. If there is a single log with the same base on each side, you can cancel them out. So like for number 5, we have log base. Remember, if you can't see it, it's log base 10. So log base 10 of x squared equals log base 10 of 2x minus 1. Now in this case, it doesn't really matter what the base is because they are the same, so we know that we can cancel them right away. So this becomes x squared equals 2x minus 1. Now it's just a normal equation to solve. So if it's a normal equation with no quadratic, you would just solve it normally. In this case, since it is a quadratic, we're going to need to get it equal to 0, put it in standard form, and see if we can factor or then have to use the quadratic formula. So I'm going to subtract 2x and add 1 to get x squared minus 2x plus 1 equals 0. So I know that x minus 1 times x minus 1 is the factored form of that. So if I set x minus 1 equal to 0, x will be positive 1. And remember, just check and make sure that positive 1, when you plug it back in up here, doesn't give you a negative inside that argument, inside the parentheses. So 1 squared is 1, and 2 times 1 is 2 minus 1 is 1. So positive answers, good to go there. It is possible to have no solution. That is a possibility. So for number 6, in this case, there is a single log, but there's not a single log on both sides. So this is going to be the case where we're going to undo the log expression. And remember, that's log base 10. If you don't see a log, it's log base 10. If you don't see an index or a root, it's a square root. If you don't see a power, it's a power of 1. These are all things you guys just need to know. So we're going to undo that, and this will become x plus 5 equals 10 squared. Base of the log becomes base for your exponent. And then it's just a normal equation. So x plus 5 equals 10 squared, which is 100. Subtract 5, and we get x to be 95. That's it. So cancel the logs or undo the logs. 2 options of solving these types of equations. So go ahead and try number 4. I'm going to go ahead and do some more examples. So this is a good one to look at. Now same thing again, these are going to be log base 10s because we don't see a given base to us. But because there's 2 on the left and 1 on the right, we can't just say log base 10, log base 10, log base 10, cancel, cancel, cancel. We need to make the left side into one side, or one log. And we're going to do that by using our properties of logs, and we're going to condense this. Condense the left side. So when we do that, remember, you're looking at your sign. So when we have addition, we're going to multiply the expressions together. I'm also going to use my property for exponents and understand that this 2 on the outside is really an exponent for that argument, for the big part, for the x. So let's rewrite this. I'm going to write this as log of x squared plus log of 2 equals log 8. So, like I said, that addition means that I'm going to multiply x squared and 2 together. So this will now become log of 2x squared equals log 8. Now, single log each side, now they can cancel. You can't cancel until there's just 1 on each side. Then, simple equation of 2x squared equals 8. You can bring it over, guys, but what's going to happen is because there's no b term, there's no x, we can really just solve this by using our square root. So x will equal positive or negative 2. But can't have negative values. So x really just equals 2 here. You can't ever raise anything to a power and get a negative value. You can raise something to a negative power and get a value less than 1 as in a fraction, but you'll never be able to raise anything to a power and get a negative value. That's why you can't evaluate for negative values inside a log. So based off of this example, go ahead and try number 13, guys. I'm going to do number 14 with you. So this is the same thing that we've been doing. We're going to use our properties. Now what's going to happen is that this one only has logs on the left side, not on the right. So this isn't going to be a method where we're going to condense it and cancel them. This is going to be a method where we're going to condense and undo. So we do still want to condense this side, and remember that when you have subtraction, it really is going to become division. So we'll keep the log base 3, and it will become log base 3 of 9x divided by x minus 8 equals 4. So here is where we're going to undo the log. That will now be gone. And we have 9x over x minus 8 equals 3 to the 4th power, which is really 81. So we're going to multiply both sides by x minus 8, really x minus 8 over 1. Because that's going to get rid of that denominator and make that left side no longer be a fraction. But the right side will have to distribute 81 times that x minus 8. So we'll have 9x equals 81x minus 648. I'm going to subtract my 81x. That negative stays with the 648, and then divide by negative 72. So x will be positive 9. So your two methods are to still either cancel the logs or undo the logs. It's just a matter of figuring out if you have to condense anything within your equation before you can use one of those two methods.